Why would we need to reinvent financial modeling after all? Well, there are many reasons. The biggest one probably the widespread use of Excel and the dangers associated with it. If you have no idea what I mean, just get and read, for example, the ebook by F1F9 about capitalism's dirty secret. Or visit the European Spreadsheet Risk Interest Group's website. So even though there are big problems to solve, I doubt that Apple does consider financial modeling as their next big thing. They are certainly interested in completely different stuff like Apple Car or whatever. But just in case Apple would consider to reinvent financial modeling, what would it look like? What would they do? And since Apple won't do it, I had to do it myself, single-handedly. Let me tell you what I did to reinvent financial modeling by addressing just two but very important aspects. A better OS and user interface. Powerful, intuitive, transparent. When you search the term financial modeling, the first suggestion you get from Google is Excel. When you learn that someone is engaged in financial modeling, you almost instantly think of her as an Excel wizard. If you will, Excel is kind of the operating system for financial modeling. And it is the interface we create, work with, or look at financial models. This choice of tools seems obvious since financial modeling has, to a large extent, to do with numbers and calculations. And Excel is good at dealing with numbers and calculations and makes it easy for everyone to build individual calculation models without knowing much about programming and the like. But Excel, or better spreadsheets in general, is not well suited for modeling. I think Apple would get rid of the command line-like interface of the typical financial model, the spreadsheet, in favor of a graphical user interface. Spreadsheets like Excel primarily display numbers. The logic and relationships within a model are practically buried underneath a sea of numbers on a grid. A fundamental problem of Excel is its interface paradigm. The grid metaphor is good for displaying numbers, but not for showing the flow of logic or dealing with multidimensional data. To explain this problem of Excel, I often use the following picture. A model has basically three layers. The structure, this is the qualitative relationship within the model. Second, the formulas, this is the quantitative relationships between variables. And third, this is the concrete numerical input and output. In Excel, the first thing you see is the numbers. Then you can dig deeper and look at the formulas. Formulas in Excel use an arcane code of cell coordinates rather than meaningful names. But that's another story I wrote about in a recent article. The overall structure of the model is still much harder to discern, if at all. The grid layout is simply not made to display this kind of information. That's why I use Analytica for the modeling OS. Analytica, in a sense, turns this Excel paradigm upside down, or better, on its feet. The first thing you see in an Analytica model is an influence diagram showing the flow of logic in the model. These influence diagrams, which can be hierarchical or nested, by the way, show the big picture and let you build and navigate your model visually. This is as revolutionary as the first graphical user interface. The GUI was for using computers. The GUI was the essential revolution. It enabled everybody to use and understand a computer within small time. The Mac GUI superseded command line interfaces that were only known by specialists and became a paradigm for human-computer interaction. Through this GUI, you can drill down to the other, more specific layers of the model, the formulas and the numbers, which are always just a click or a keystroke away. And like Apple's operating systems, Analytica is not just a toy, it is a very powerful development platform that allows for multidimensional calculation with huge amount of data, fast Monte Carlo simulation, solvers for all kinds of optimizations, and more. The second thing is a generic approach to three-way financials. Simplify complexity. The holy grail of financial modeling seems to be producing an integrated set of the three fundamental statements: income statement, balance sheet, and cash flow statement. Although it's common knowledge how these statements are interrelated in principle, I've seen many slightly different ways to reconcile the three. Almost all of them are somewhat complicated and are not really elegant. So the typical procedure to come up with a three-way statement goes something like this. First, project some line items for income statement and balance sheet based on margin and ratio assumptions. Second is calculate assets by using CapEx and depreciation. The third thing is build the cash flow statement by tying together net income from the income statement and periodic changes from the balance sheet. The fourth thing is calculate equity based on previous period and the period's net income, as well as dividend payouts and equity contributions. Then fifth, tie together ending cash balance from the cash flow statement into the balance sheet and balance the balance sheet. And finally, the sixth thing is calculate interest expense and tie this into the income statement, trying to avoid circular problems. Now, in any case, linking and reconciling the three statements is a complicated, error-prone, and time-consuming task. My observation is, and I don't exclude myself here, that financial modelers spend as much time building integrated financial statements as modeling the underlying business and performing analyses. For years, I was thinking there must be a better way. To me, many of the problems with three-way statements are caused by using shortcuts. Shortcuts might be useful, as the term suggests, in situations where you need quick results, but they typically come at a price. A shortcut is never the result of deep thinking. My passion, however, is to think deeper. I get an uneasy feeling when things are not clear, when things don't make sense for all instances of a problem, and things are unsystematic. After years of building three-way models from scratch and trying to reconcile them this way or another, I decided to think through the problem and came up with a systematic, elegant, scalable, always working solution that took advantage of Analytica's modeling power. This is the Economic Financial Modeling Framework. The core of the framework is the three-statement financial model. The idea behind the framework is to separate the financial model from the operational model and link those two via a simple, standardized connector. The three-statement model keeps track of all relationships that tie together income statement, balance sheet, and cash flow statement, which is tax calculation, dividend distribution, cash balance calculation, and interest calculation on cash balance. These relationships are solely financial, and they are the same for every financial model regardless of the underlying business logic that drives the numbers, because they are defined by the nature of dual accounting. They represent the common language in which we describe the financial situation of a business. That means the individual structure of the income statement or the balance sheet might vary, but the basic logic is always the same. The framework contains a basic structure of the statements related to IFRS, but can be adapted to individual needs. To keep the diagram for the three-statement model compact enough, most sub-calculations, for example, operating profit, are capsulated into submodules. This way we can explore, navigate, and explain the financial relationships between the three statements. This is extremely useful when you speak to non-financial experts, managers, etc. After experiencing a live demonstration of Analytica, the CEO of a multi-billion-dollar polymer company exclaimed, "I never truly understood the relationships between profit and loss, balance sheet and cash flow statements until now." But the best thing about the financial modeling framework is yet to come. And here's the trick. The statements in the framework are fed via a so-called universal connector, which is basically a spreadsheet-like table that contains the lowest level items of the three statements: balance sheet, income statement, and cash flow statement. The smart thing, however, is how the numbers are generated. You do not model each line item one by one. Instead, you model things I call business transactions. These transactions can be as small and simple as a one-off sale or as large and complex as an entire company. The only requisite here, and that's the actual trick, is that they produce all relevant direct effects on the three statements. For example, if you have a very simple sales model, it needs to produce numbers for the income statement, cash flow statement, and, since there is a payment term, the balance sheet. The cool thing, however, is that if you send only those numbers to the financial statements in the framework, they will be all correct and consistent. The income statement will just show revenue, and the numbers would go unaltered all the way down to operating profit. Since we're piling up cash, there will also be finance income based on an interest rate assumption in the framework. And of course, there will be income tax also automatically calculated by the framework. The cash flow statement will show the direct effects of cash receipts, but also the indirect interest received on cash, which is calculated by the framework. The framework will also calculate the income taxes based on the assumed months of tax payment, as well as the dividend distribution shown under cash flows from financing activities. And finally, the balance sheet will be balanced, containing all the relevant asset and liability positions, as well as the development of equity. Of course, a three-way statement solely based on the sales part doesn't make sense in itself, but do you see the potential? This approach means we can simply add up multiple things, from the simple to the most complex, and as many as we want, and always get correct, consistent statements. This is very handy and powerful. Take an existing planning of a whole company and add another planning of another company, plus consolidation and synergy effects and financial transactions for evaluating M&A transactions, for example. Or take an existing planning plus risks for analyzing enterprise-wide risks. Or take an existing planning plus strategic projects and initiatives for a strategic planning. And of course, a complete driver-based planning model. The framework comes with a functionality that allows to easily match and mix various parts of a model into strategies. You can compare the results for each strategy side by side, either as numbers in table, graphically, and of course, for any item, ratio, or KPI, even as the result of a Monte Carlo simulation. With the framework, you can really concentrate on the logic behind the numbers without worrying about how everything fits together. You can simply break down every problem into components you well understand and model their direct impacts on the three statements. Just check if they are balanced and everything will be fine in any circumstance. Then you just need to add them up, literally, to build greater, more complex structures. The framework frees modelers from mundane work, empowers creativity, and makes good concepts really work. For example, agile development, rapid prototyping, or collaborative modeling. The surprising thing is, simplify complexity allows you to build even more complex models. With the financial modeling framework, I try to simplify complexity. Real-life models can be quite complex because the reality they aim to model is complex. But that doesn't mean they need to be complicated. Complicated things like a clockwork or a car engine work pretty well for the purpose they are built for. But they are not very well suited for other tasks. Simple things like Lego bricks or the DNA molecules, in contrast, can be combined in many different ways, allowing for immense complexity. The framework makes the components of financial models as simple and generic as possible. The framework is the DNA of complex financial models. The proof of the pudding is the eating. Testing the framework in the wild. The financial modeling framework is the most generic approach I could come up with. It's based on 10 plus years of experience, condensed to the essentials. For many years now, it serves me quite well in my own modeling engagements. It's still work in progress. It still needs refinement and testing and documentation. But I think it's time to share it with the world. If you feel you want to test the framework, either for yourself or together with me for your modeling project, just drop me a line and contact me directly. I would be glad to hear your thoughts. Let's reinvent financial modeling.